All right, boys and girls, welcome back to the drive-thru. Hungry? Stop by the deli. Make yourself a Philly cheesesteak sandwich. Traditional. Onions, mushrooms, banana peppers, mayo. All right, we're continuing in our lecture of 10-5, and we're going to talk about how to find the angle between two planes. So first, I'd like for you to imagine two planes that were orthogonal to each other. Okay, now, hopefully you understand that a plane is defined by the vector that's orthogonal to it. So let's think about this vector n. And that vector there, m. If we wanted to find the angle between these planes, well, we know that we have stated, part of our given, that that was a right angle. Well, maybe you notice that the angle, remember, vectors do not have a location, so I can just move that black vector over there. Maybe you noticed that the angle between the vectors is the same as the angle between the planes in that instance. Okay, so let me draw another circumstance for you. Eek. Okay, and now let's make this plane so that it is not orthogonal to each other. So now we've got this angle here that we're trying to find, the angle between two planes. Now, one thing I want you to remind you is that planes either intersect or they're parallel. Okay? There's no such thing as skew planes unless we're talking the fourth dimension. Whew. So let's go back. Let's draw our n here. This vector. And looks like this plane is defined by that vector. Let me just remind you that planes are defined by the vector that's orthogonal. And it's really hard to envision this, but maybe, hopefully, this picture helps you understand that if I move this over here, this angle theta is the same as that angle theta. So, if we have a plane defined by n, and let's say that n is the direction vector of the plane, the direction of the vector that's orthogonal to plane, and if m is also a vector, then to find the angle between the planes, we would just say cosine theta is equal to n dot m divided by the magnitude of n times the magnitude of m. Okay? So you should recognize that. That's the angle between vectors formula. So if we wanted to do an example, and let's say we find the angle between the plane represented by x minus 2y plus z equals 0, and the plane represented by 2x plus 3y minus 2z equals 0. All right, so the direction vector of the first is 1, negative 2, 1, and the direction vector of the second plane is 2, 3, negative 2. Okay, and we're just going to say the cosine of theta is equal to 2 minus 6 minus 2 over magnitude of the green vector would be 1 plus 4 plus 1, so 6. I don't know how to notate that. We'll just do that. Times 4 plus 9 plus 4, so times 17. 4 plus 9 plus 4, yep. And so you get a -6 over, excuse me, these are radicals, a -6 over radical 102. Okay, so cosine of theta is equal to 0.59409. Take the cosine inverse of both sides, and you get theta is about 53.6 degrees. Stay tuned for more. Boom!